Okay, Fred, Julian, and I, my department head, we're at the Laramie workshop. Doug did a great job leading that workshop, and Christina was there, and so I recognized her right off when I got here yesterday. And Fred and I were very excited when we left the workshop, and we were determined that we were going to get something done. And we really had some preconceived ideas about what we wanted to do with it. We saw how it fits readily into our program. When we met, the way we got to the workshop was we were involved with Steve Wendell and Tom Singer in a leadership conference, and that's when they started talking about the stem guitar thing. And one of the things that really piqued my interest is the kit building operation that they had, because then it mimicked a real business, which seems to be the thing missing with our connection with our manufacturing, engineering, and technology program in the real world. Is, how can we have a real life business that we could use as a model? But ultimately, what we wanted to do is be able to develop an entry-level course, manufacturing, engineering, technology, that we could use the STEM guitar program to draw kids from high school into our program, to find out what that manufacturing, engineering, technology is really a cool field of study. So that's the reason why we have aligned the STEM guitar building with manufacturing, engineering, technology curriculum presentation for you. So we just look at the definition of, or what the National Center for Education and Statistics says, that really manufacturing, engineering, technology is about solving problems in manufacturing. It's really about building manufacturing systems that will build quality products with zero defects and doing it in a productive way. So a lot of the things it includes in the instructions are the things that you'll see in the presentations, where we're doing a machine operation, production line operations, engineering analysis like failure mode effects analysis, systems analysis, physical controls like control plans and things like that. They're all part of the quality control is what we're really looking to build upon. And we were already teaching something in the program called Advanced Product Quality Planning, or APQP. And we'll show how we use the STEM guitar program to tie that together. APQP, if you're not familiar with it, has been a hallmark methodology for the automotive industry, but it's now being used in a lot of other industries like aerospace and defense and the medical industry. So our introductory course now uses this, some practices along this with the STEM guitar to introduce the student to the program. So after we had went to the workshop in 2015, we came back and my second year students were ready for their capstone course. So we used this program, we used the capstone course to actually build the workshop, the STEM guitar workshop. And we had a couple of, and this is Team 3, a picture of the Team 3, and there's the guitars that they built. But they were in charge of the phase of guitar building where you put the frets in and also build the electrical circuits. And there were a couple of project goals that we were looking at with the MFT 250 capstone course. And the first one was to build quality into the guitar building product and process using advanced product quality planning, also known as Design for Six Sigma. And the second one was to launch a lean guitar building operation using production preparation process, or what's called 3P, if you've studied anything about lean. And that's really my second presentation. So what we're going to focus on here is building quality in. It's really based on the Automotive Quality Management System standard that you see there on the right side, which is now went to IATF 16949 2016 just this year. This kind of a summary slide of what happens when you're teaching this. So you go from the, let me put my pointer on so I can point to it here. you're really going from the voice of the customer. VOC is the voice of the customer. That's the end user or the OEM that's going to build the product, whatever the product is, all the way down to the voice of the process, which is when we do our production part approval process at the end. And all the way through this thing, there are linkages called special characteristic linkages. In other words, what's most important about the safety, fit, form, function of building a product. And special characteristics is really, that's the definition that you see there. So from the very beginning, when we find out what it is that the customer is looking for and what they want, in this case with the guitar, the student is the customer, they're building their own guitar. But we start out by showing them a block diagram which shows the relationships, and then go through these what we call core tools, and I'll take you through each one of them. In other words, this is the relational block diagram for guitar. And you can see the main parts are the guitar body and the neck. Of course, the truss rod goes inside the guitar. So what you're seeing here is each one of these boxes is a component. And the component itself can fail, that would cause the guitar to fail. Or the connection, or the attachment method between components, because we know that if the fretboard isn't put on the neck right, there's a failure. If the frets are not down all the way, it can cause the guitar to buzz. If the nut's not just adjusted properly, the string height is off, the guitar can fail. As far as safety, the safety item, we ground the bridge, so there's an electrical connection there. So we start to see that these are the things that are important about the product quality that we have to build into the process in order to get a quality product. The next step we do is, and you probably can't read this, but I'm showing you, and you'll be able to see the handouts. This is a design FEMA, and so what it does is it asks what could go wrong in the way the product is made that could cause it to fail, either in the component or in the attachments that we look at. And so for each one of those components and attachment, we ask that question, and then we write down what the failure could be, what we're trying to accomplish, what the failure could be, then what the severity is. And we look at not only the severity of what would happen if that component failed or that connection failed, but also how often it occurs is the occurrence. And then finally, the detection. In the process, will we be able to detect it so that we can prevent it from failing before we actually finish the guitar and ship it? And that gives us a risk priority number, which helps us to kind of Paretoize what we should be working on first. And you can see that this list of risk priority numbers here that we picked up on the top few risk priority numbers, and then put actions together to reduce that risk. And then we can calculate new numbers to reduce the risk. This is something that's used in APQP across the industry, but we've seen it applied to the guitar. And this is really the part that the entry-level students, these it's not going on for some reason.
You need to switch to your pointer.
It says start the program, wait for the program to respond. Oh, there it went. It just went. Okay, what we really focus on in the 101 class, because it is manufacturing, engineering, technology, even though we do some study of the product, we're more interested on how the process, how we affect the process. So this is where we really pick up is, okay, so now that we know what the design of the product is, the students have to make their own process flow diagram. And this one is about the neck. This one was made by the 250 students for the guitar neck and body preparation. But what we do in the intro-level class is have them do it for the electric circuit. What are the process steps of building your electric circuit in your guitar? And then once they've done that, they do the same thing, only this with a FEMA, only this time it's a process FEMA instead of a design FEMA. In other words, instead of looking at the product failures, we're looking at the process failures. And we do somewhat of the same thing. Every step of the process, we ask what could go wrong in this step of the process that would cause the guitar to fail to perform the way it's intended to operate. And you can say in this case that Sir Johnson, who was on that team, has some work to do that he's supposed to have done by the end of the school year this year, by the end of December. So we don't have the final analysis done on this. Then the next thing that comes out is out of the control plan. For some reason, it's not one.
It's hanging on.
There it goes. Another engineering document. This is actually the last engineering document where what we're doing is taking what we've learned from the product and the process and we're putting it into a control plan. And this is the plan that we could use to audit the process to make sure that the guitar is being built the way it was designed to be built, or any other product for that matter. And you can see, you notice with these, and I won't go back because it's going awfully slow, with each one of these documents you see these special characteristic symbols being carried from document to document. It's not that we're not trying to control each one of the steps of the process, but there are certain steps that are critical to the functioning of the guitar itself. So we make sure that we carry those over. We know how we're going to measure the guitar and monitor it. We know what reaction plan that we're going to take in the event that a step doesn't work the way it's supposed to. Now these aren't too good for operators, especially for new luthiers to work on the line, but they're good for engineers. And they're good for students to learn how to engineer the process. So the next thing we do is we turn this into a work instruction. So here you see just a part of the work instruction for the guitar body prep. And this is we have other kinds of work instructions that actually have narratives that talk about each one of the steps and why you do it. And we give that to them before they actually go into the lab. And then when we demonstrate, we have these job aids there available to them. Because one of the things, Doug knows exactly what to do, and inside and out, but he'd tell me what we were going to do for that afternoon, and by the time he finished telling me what I was going to do, I forgot the first thing he told me to do. So one of the things we want to do is remind the student of what they've already learned and why they're doing what they are, and we want to make that really simple for them. And then the last thing that they do is the production part approval process. This is the end of the project. Have we actually covered all the things that the customer needs changed? And there are 18 different items in the part approval process. But really for the entry-level course, all we're doing is we're looking at the customer's engineering records, which is given to them. This information is given to them. Then they have to develop their own process flow diagram. In this case, they're doing it for the electric circuit. And then they develop the process scheme and control plan, and then they convert the control plan into operator instructions. So there's really two courses going on. There's a lecture course, this is what's going on in that lecture course, and then there's a lab course, which is the course that they build the guitar with, and they're doing both of those. So they're learning this process while they're in the entry-level course, and then the lab portion of it is where they actually build the guitar plan. And they also do all the lessons, go through all the MLAs that are on the site along with that. So the benefits of aligning the STEM guitar building program is the STEM guitar lessons already include concepts of technology and engineering, but the APQP core tool exercises provide the means to apply manufacturing engineering methods directly to guitar building process. And as you all know, almost everyone thinks guitars are cool. So being able to apply these concepts while building your own guitar allows the luthier to empathize with the voice of the customer. They are the customer. They are the customer. They're building this for them, so it puts them in the customer's position. And they should determine if they are interested in pursuing a career in manufacturing engineering technology. I was telling Christina, we were talking about what this lady was saying right before lunch. And manufacturing's become a bad name. Somehow it's gotten a bad name. And it's really a great opportunity for people to enjoy a really high standard of living. And by getting them involved with something like making guitars gives them the chance. Remember Christina said in her presentation, see, these girls now think they can make anything. And that's what my students come out, wow, I made this, what else can I make now? What else can I do? And then last, learn the fundamentals of how to develop a robust manufacturing process for producing guitars or any product for that matter. Any questions?